Yes, what it's going to be doing is the data that it's collecting is actually information about the angles that it's at. And we're doing that using this accelerometer. And so depending on the voltage that it gives out, it's going to correspond to a certain angle. And we're using stepper motors to know the exact displacement that the robot has traveled, because we can control the position of the motors with that. And so we're just using the simple geometry to actually go and, like figure out the height and the horizontal distance that is traveled. And the way that the computer is getting the data is through a Bluetooth device. I'm not sure if you can see it right here, but it's just going to be wirelessly streaming it to the laptop. And so these two right here are the distance sensors, so it knows whenever it gets to the wall, and it'll go and turn into the next column. Because of the fact that it is traveling up and down hills, it's frequently becoming disoriented. So in order to solve that problem, to keep it on a straight path, we went ahead and added a line detector subsystem. And so it's going to follow this line to make sure that it collects the data in a straight path, so we can get as accurate readings as possible.
Well, the issue that we had was torque. We didn't have enough torque for the actual curve.
Kind of like guiding it.
So yes, we just helped it along, and it still does what it's supposed to do: line detection and wall detection, or obstacle.
Okay. So yeah, this is fire it up.
Okay, you have the Bluetooth.
Guess roughly how long does it take to convert?
Minutes to 2 minutes.
Oh, okay.
We haven't actually really timed it yet.
It's not the fastest.
Yeah, it's not the fastest. Right? We tried to, because you can adjust the amount of torque to the speed, so we tried to get an optimal amount of torque on the wheels.
That's a lot of G.
It's very good. Accurate.
Want to put it?
The data.
It started over again. Yeah.
So it's a front wheel drive?
Right. We had two motors on the back, two stepper motors on the back, but they weren't really pushing any weight. They were just making the wheels turn, which is good for traction. But the problem is the battery we had.
Okay, thanks for making it out, man.
Rating for the amperage. So we were worried that it wasn't gonna, get enough
Is it
power.
streaming the data? You have to resync the device.
Oh, really?
Because you turned it off.
It reorients itself, but since the slopes are so steep, sometimes it slides without being able to reorient fully. Like if it were on the ground, just on a level surface, it works perfectly fine. It's just the fact that this is a rough surface. When it gets off, it accelerates down at that speed. So we have to adjust it.
And now it's so that's correcting itself.
Right.
It's turning as it keeps going off the line.
Did you say you were using stepper mode?
Right. That's part of the reason why it's so jumpy. And then it gets to the wall.
You govern the turn by steps as well.
Right. Right. It says it says once it hits the wall, it switches the direction of the wheels to turn and moves a certain number of degrees.
And pick up the middle one.
Right the turn.
So it's collecting data right now and wirelessly transmitting.
Right, yeah. It's currently collecting data as it goes. So it collects a lot of data points. put it into a text file just by writing a program. Log maps kind of maps out
Oh man, it didn't detect the line. No, it never detected the middle line. Yeah, you. Until the middle line sees it.
lost the line.
Okay, so that's what he's doing right now. And
Points in the middle, and then the red points and the brown points correspond to high points on the edges.
so we try to do it by the color spectrum. So as it gets lighter and lighter colors, it's going to be lower elevations. And then when it gets darker colors like red, it's higher elevations.